Okay, welcome back to another Physical Sciences 3 lecture. This is the final Newton's second law example that we have. It's on page 38 and it is example 10. And in this example we have a man of mass 100 kilograms, oops, that's a funny M, mass of 100 kilograms slides down a rope that can support a weight of only 750 newtons. Okay, so he slides down it, and how is this possible? So what they're saying is that the force of gravity of this man is equal to 100 times 9.81, which is equal to 981 newtons. Okay, so how is it that a man can slide down a rope that can only support 755 newtons when his weight force is larger than this? Well, because he is not moving, because he is moving, sorry. So because the man is moving, the rope does not have to support his full weight force. Okay, it means that the man is actually have to be. It means that it will be accelerating. This implies that the forces are not balanced. And the man is accelerating. Downwards. Okay, so and I guess the friction between the man and the rope is causing the acceleration to be less than if there was nothing there. Then we can say that as well. So the frictional forces between the man and the rope are lessening the acceleration downwards compared to if the man was in free fall. So basically all I'm saying there is if the man was just falling, he'd be accelerating at a larger rate than if the rope wasn't there. So if there was nothing there, the man would just fall due to gravity, and his final velocity when he impacted on the earth would be much larger. So what is the least acceleration he can have without breaking the rope? So we kind of imagine, so we have this force upwards and force downwards. So force gravity is going downwards and the friction force is upwards, or the tension force would be going upwards. We have so for it not to break, our net force, so this is of the man sliding down, must be equal to, we'll make upwards positive again. So we say Ft, so our tensional force, minus Fg. Okay, so Fnet is equal to Ft minus Fg, and so the net force, Fnet, the maximum has to be 755 minus, what is his weight? His weight's 100, so minus 755 minus 981, which is what we calculated. Okay, So F net then, the maximum F net for the rope to break. This would like if it was if the tension force was 755, then it would just be at breaking point. So what is that equal to? 755 minus 981. 226, so negative 226. And then our F net is also equal to the mass of the man times his acceleration. So it's going to be 100 times A equals negative 226. So then A is equal to minus 2.26 meters per second squared, which is equal to 2.26 meters per second squared down. So it's a lot less than the gravitational acceleration. Okay. Where did that come from? Oh, I see. When I scrolled up, so I must have taken that 5 up there. I was thinking, what is this? Let me get rid of that. Okay. Yeah. So good. So we're 2.26 meters per second down, which is a lot less than 9.81 meters per second squared downwards. What will be his minimum speed after sliding down 8 meters? 6.00 meters. Okay. So his minimum speed. So let's assuming that his minimum speed. So that would be according to the least acceleration. So we have to use the acceleration we just calculated, S, U, V, A, and T. So S is 8.00. U, and I think this is just the answer. So they've actually given us the answer, which is nice of them. After sliding down. So minimum speed, so this is all vertical, so he's starting off with 0 meters per second. And we're trying to find what his minimum speed is at the end. 2.26 is his acceleration downwards. And in this case, downwards positive, just so we can keep everything positive. So his final velocity, v squared, equals u squared plus 2as. V squared equals 0 plus 2 times 2.26 times by 8.00. V squared is then equal to, let's have a look. Well, so we got 2 times 2.26 times 8, 36.16. And then V is equal to the square root of 36.16, which is going to be close to 6.00. Let's have a look at it in exact terms. .01. Okay, the speed doesn't need a direction, but anyway, 6.01 meters per second. Squared. Okay, and I will just make a quick comment about this. If a question ever says show that, let's say that in this question they were actually saying show that his minimum speed would be 6.00 meters per second after sliding down 8 meters. You always want to go to like enough decimal places so that, get rid of this sign. Glad it's told me. Enough decimal places to show that you've actually worked it out yourself. So 6.01 meters per second down. That was the last example of Newton's second law. And we've got Newton's third law next. And this is the time I'm sorry, I'm going to clear my throat and then I'm going to charge my pen and we'll see you next time.